Hi guys, so today we're going to be looking at chapter 10 section 3 on two-way tables and probability. So let's look at a two-way table. A two-way table is a frequency that displays data collected from one source that belongs to two different categories. So right here is an image of a two-way table. And over here, the 25, 80, 44, and 32 is called the joint frequency, which is the data that has been collected. So, for example, 25, that means that we have here the freshmen and the attending, which if I were to understand, like write it in a sentence, I would say that 25 freshmen attended an event, while 44 freshmen did not attend an event. Okay. If I were to look at the 80 sophomores attended the event, but 32 sophomores did not attend the event. Okay. And so what we can do is we can create marginal frequencies, which would just be the sum of the rows and columns. So for example, if I want to see how many sophomores and freshmen attended, all I need to do is add up the 25 plus the 80, which would equal to 105. So in total for the freshmen and sophomores, 105 of them attended. While over here, if I were to add up the 44 and the 32, that would equal to 76. That would mean that 76 of them did not attend. And the data was collected, or we collected, let's see, 25 plus 44. So we collected data from 69 freshmen, right? And we collected data from 30 plus, oh sorry, not 30, but 80 plus 32, which is 112. So we collected data from 112 sophomores. And so this is how we are going to be understanding the two-way table. Let's try to make our own. So I have a two-way table here. And we're asked here, in another survey, similar to the ones above, 106 juniors and 114 seniors responded. 42 juniors and 77 seniors planned on attending. Organize the results in a two-way table. Then we're going to find and interpret the marginal frequencies. So let's start off first by adding in the data that we do know. So number one, let's talk about the 106 juniors and 114 seniors that have responded to the data. So I'm going to write down on the side that we have juniors and we have seniors. And in total, we had 106 juniors. And I'll write down that this was the total area. And in total, we had 114 seniors. Cool. Let's go to the second part. So the second part says that 42 juniors and 77 seniors plan on attending the event. So that would probably go in either attending or not attending. This one would be in the attending section. Attending, not, oh, wait, hold on. Not attending. So this becomes more specific because not only does it tell us what year they are or what class they are, but it tells us if they are attending. So that would go into this section right here. So juniors and attending would be in this box. So I would put 42 here. Then 77 seniors attending, that would be in this box. 77. Cool. Then, because we have these data points provided to us, I know that 42 people are attending based off of the 106 data points that were made. So that can also help me identify who did not attend based off of the amount of data points given. So all I need to do here is subtract 106 minus 42 to see how many juniors said that they are not attending, which would equal to 64. Same thing goes over here. I could find out how many seniors are not attending by subtracting 114. 114 minus 77. So that would equal to 37. Okay. And then based off of that, we can identify how many students are attending. Right here, if I were to find the total of students that are attending, we just have to add 42 plus 77, which equals to 119. And then the total amount of students that are not attending is going to be 64 plus 37, which would equal to 101. So those is the total that are not attending. And so based off of that, we could also identify the total amount of people that were surveyed. So all I need to do here is either add up the 119 plus 101, or I could add up the 106 juniors and the 114 seniors. And that would give me the total of people that were surveyed. So either way, let's just add 106 plus 114, and we would get 220 people surveyed. Cool. So after creating our two-way table, other things that we can look for are the relative and conditional relative frequencies. There's a few of them that we can look at. One being the joint relative frequency, which is the frequency divided by the total number of observations made. Marginal relative frequency is the sum of the joint relative frequencies, so adding them all up together. Then the conditional relative frequency is finding out what the joint relative frequency is and dividing it by that marginal relative frequency. So let's try it out. Let's look at the same problem as we did earlier. Okay, still exactly the same. We're still looking at the 106 juniors and the 114 seniors. Okay, and so far, based off of our table that was made, and I'll write it right here, we had 42, 77, we also had here 64, we had 37, and the total amount that was surveyed was 220. Okay, so the question that they're asking here this time is to show the joint and marginal relative frequencies. Okay, so if I'm going to find out what the joint relative frequency is, all I need to do is take all of my frequencies, the 42, the 64, the 77, and the 37, and divide it by, right here, I'm going to divide them all by the total amount of people that were surveyed, which we found out was 220. So 42 divided by 220, 64 divided by 220, 77 divided by 220, and 37 divided by 220. So let's figure out what that equals to. This is going to equal to 0.191. We get 0.291. We have 0.35. And we have 0.168. And so pretty much, for example, this one, we could just change it into a percentage. So 0.291, move the decimal point twice, and so we get 29.1. And what that means is that 29.1% of juniors, right, those juniors did not attend. But 51.8% of the seniors are also not attending either. Okay, so the marginal relative frequencies. All I need to do now is add up the total of the joint relative frequency. So I'm going to go over here, add up 0.191 and add it to the 0.291, which would equal to 0.482. Okay, and then over here we have 0.35 adding with 0.168, which would equal to 0.518. And again, this just tells us the percentages. So we have 48.2% of juniors that were surveyed. We have here 51.8% of seniors that were surveyed. If you find out the total here of seniors and juniors, it should equal to 100%, or just when you add up those two numbers, 0.482 and the adding up 0.518, you're going to find out that just equals to 1, which is 100%. And then over here, we want to identify the percentage that did not, or attended, and the percentage that did not attend. All I need to do again is just add up 0.191 plus 0.35, which would equal to 0.541. And then on the other side, the percentage that did attend would be 0.291 plus 0.168, which would equal to 0.459. Done. Okay, cool. The last thing that we're going to be looking at is the conditional relative frequency. And we're going to be finding the conditional relative frequency based on the row tables. Okay, so if you look at the row tables here, I am going to take the row sections. So I'll take the frequencies, percentages that were made here, and then I am going to take the total amount and divide them with each other. And that will be my conditional relative frequency. Because again, they're asking for specifically row totals. Okay, so let me just write down all of the relative or joint relative frequencies, which were 0.191. Over here was 0.291. And we had 0.35, and we had 0.168. And then we found out again that the total amount for the rows was 0.482 over here, and then this one was 0.518. So again, all I'm going to do, take both numbers and divide them with each other once more. Dividing by 0.482. Dividing by 0.482. The total here was different. It was 0.518. 0.518, which would equal to 0.396. This one will equal to 0.604. Over here we get 0.676, and we get 0.324. Okay, so all this is telling us is that given that the student is a senior, right, the conditional relative frequency that they are not attending is going to be about 32.4%. And that would be my final table. All right, so now that we understand how to create a table, we're going to be using the table now to interpret some probabilities. So, for example, a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend, and the result given as joint relative frequencies are shown in the two-way table. So, what this is telling us here is that they're asking here, saying that would you recommend the TV provider to another friend? Some people said, yes, I would recommend this TV provider. Some people said no, and it was also had locations. So in Glendale, 29% said yes, I would recommend this to another friend. In Glendale, only 5% said no, I would not recommend this TV to another friend. And the same goes for Santa Monica and Long Beach locations. So the question here was asking, what is the probability that a random selected customer who is located in Glendale would recommend the TV provider? So it's important to understand what your overall outcome is. So I'm looking at specifically Glendale, right? That would be the overall outcome, and specifically from Glendale, who would recommend this TV provider? So again, the bottom of my fraction will always be the generalized survey, or like the group that I'm looking at, which is Glendale. Okay, so from Glendale, and then the top is always going to be giving me more specifics. So from Glendale, which people from Glendale, again, said yes, they would recommend the TV provider. Okay, and that's the probability that I want to be looking for right here. So I'm going to start off first by identifying how many people were in Glendale that they surveyed. Right here it shows that it was 29.29 plus 0.05 people were in Glendale. And again, the specific yes part in Glendale was the 0.29. 0.29. Which, if I were to calculate it, we get 0.853. So, if I want to change this to percentage, 85.3% said yes, they would recommend their provider from Glendale. Done. Okay, what is the probability that a randomly selected customer now, so it's just a randomly selected customer, could be from any of the locations that were provided, would not recommend the provider and is located in Long Beach? Okay, so again, the overall generalized statement is that we're just looking at anybody. So it could be Glendale, Santa Monica, or Long Beach. But again, it's not going to be those that were would recommend it. It was actually those that would not recommend. So I would be looking in this section. So I'll write here my probability statement. I like to write the probability statement just to kind of remind me what my idea here is. So my probability here is no, I would not recommend. Not recommend. Could be anybody from either any location. And the idea is that they it says here what's the probability that selected will not recommend the provider and is located in Long Beach. So specifically, no, and is in Long Beach. Long Beach. So they get more specific later on. So if I'm going to look for this one again, the no's were 0.05, 0.03, and 0.04. So I'll add those together first. Plus 0.03 plus 0.04. And the top is the part where we get more specific. It was a no and it was in Long Beach, so it'd be 0.04. If I wanted to find out the probability, we get about 0.333. Done. Okay, so the third question asks, determine whether recommending the provider to a friend and living in Long Beach are independent events. So if I want to identify if this is an independent event, I am going to be looking at the probability of the second event and see if that equals to the probability of the fact that event B happens given A. Okay. So if I were to identify the two different events happening here, we would say that recommending the provider to a friend is event A, and then living in Long Beach is event B. So let's first identify what is the probability of living in Long Beach, or that we have the survey in Long Beach here. So Long Beach survey was the following here, 0.32 plus 0.04. Okay. Then we want to find the probability that a randomly selected customer recommended the provider and is located in Long Beach. So right here we put living in, or saying yes first. Yes. Not only did they say yes, but they are also in Long Beach. Long Beach. So that formula would be yes, which was 0.29 plus 0.27 plus 0.32. And then they said yes and are living in Long Beach would be 0.32. Okay, so if I use the calculator, this would equal to 0.36. This one equals to 0.36 as well. So we end up having the same probability. 0.36 equals 0.36. So in this case, both event A and B are independent events. There's no dependency between them. You don't need to have one to do the other. Independent. Done. Okay, so hopefully this helped. Good luck.